Hi girls, Mr. Gilmore here. I'm back at you with another one of our ratio and proportion videos. This will be our third lesson and it is the 22nd of April. So what do we need to know beforehand? What are we going to learn today? Well, firstly, what we need to know beforehand in order to be able to handle this class is how to find a ratio between two things. So that would have been our first lesson. And then how to find the proportions of two things. So what we did in our second lesson. So if you're able to handle the first and second lessons, then you are 100% ready for this class. In fact, you might even find this class a little bit easy. Let's look at what we're going to learn though. What we're going to learn is the different ways in which proportions can be represented. So I've only shown you one way that you can show a proportion. And then also learn what direct proportion is. And actually, I've kept something out there. So I'm going to throw another new term we're going to deal with here, which is the unitary method. Okay, so what direct proportion here is, and I'm just going to write in red, the unitary method, okay? Now, I know both of those sound like scary words, but they're really not. They're fairly straightforward. So how do we approach this? Well, what we do is let's just first look at a normal ratio and a normal proportion. This is the same example I used yesterday. So you've got 3 red marbles, 6 blue marbles. So we immediately go, okay, that's in a ratio of 1 to 2. So its proportion is 1/3 and 2/3. And you'll notice that if we add those two together, we'll get 1, right? You know it's a correct proportion if you can add all the values together and get a single 1. Now, here we are representing our proportion in fractions. And anyone who is good at our converting values will realize, wait a second, there's 2 other ways you can express values less than 1 but bigger than 0, right? You can use percentages. Actually, you know what? I'm going to start with decimals. And you can use percentages, right? So if I wanted to express 1/3 and 2/3 in decimal form, I'd get 0.33, and then I put that little dot above the 3, wouldn't I? So that's to say, okay, these just repeats 3's forever. Similarly, 2/3, that's going to be 6's repeating, okay? So just 6's forever. Again, with percentages, you can go, okay, so that's going to be 33, and I'm not a big fan of going 0.3 dot for percentages. I'm a bigger fan personally, just going 33 and 1/3%, and 66 and 2/3%, right? So we can see we can express a proportion as a fraction, decimal, or percentage. So that's what I meant when I said the different ways you can express proportions. Now let's look at the term that I introduced, those 2 terms, direct proportion and the unitary method, okay? So direct proportion is actually not that difficult. It's literally just that the ratio as you go up stays the same. So the proportion increases kind of to the same ratio. So you'll see one of these red blocks is worth €2. 2 of these red blocks is worth €4. 3 of these red blocks are worth €6. So you can see, okay, when we add 1 onto this, we're adding 2 onto this, but the ratio is the same each time, isn't it? But you've all been in shops. You've all seen, one apple is, let's say, 60 cents, but 4 apples are €2. So that's trying to encourage you to buy more, but you'll immediately go, wait a second, there's not the same ratio between apples and percent and cost there, is there? So these are not in direct proportion, but these are in direct proportion. So assuming that chocolate bars are in direct proportion here, if 6 chocolate bars cost €9, how much would 4 chocolate bars cost? Well, we've done a similar question already. We've gone 6 bars cost €9, so what's the cost of 1 bar? So this is assuming that this is in direct proportion. What's the cost of 1 bar? So we go, okay, 9 divided by 6 for this, wouldn't we? And we'd get 1.5, so €1.50 is the cost of 1 bar. So what's 4 bars? Well, we'll immediately go, and we'll go, wait a second, that's just going to be multiply this by 4, and realize it's €6, okay? So this is what we mean by the unitary method. Notice one of the words here, unit, singular. So unitary method is find the cost of 1, and then from that you can find the cost of anything. And you could do the same thing with if a car goes this distance on this many litres of petrol, how far will it go with this much petrol? Or you could do, you could do it for so many different things. A great example of it was when we were doing that fish pie example in, I think, our first video. So the unitary method is just a way of using our proportions to kind of size up or size down. You can do it with recipes, you can do it with cost of things, you can do it for so many things. So let's do a few examples, and then I'll give you girls some work to do over the next while. Okay, so this question here, now this isn't all of question 3, I've left a little bit out here. The table shows the choices made by a class of 30 pupils going on a school trip, right? It goes copy and complete the table, okay. So how would we complete the table? So if 9 boys and 12 girls voted for bowling, how many people voted for bowling? Well, 9 plus 12, 21. If 3 boys and 6 girls voted for cinema, then 3 plus 6 total 9. Okay, so how many boys were there? Well, 9 boys voted for bowling, 3 boys voted for cinema, so you get 12. 12 girls voted for bowling, 6 girls voted for cinema, so okay, we can see there's 18 girls. So that's what that question was asking for. What proportion of boys wanted to go bowling? Okay, so we can go for question 2 there. We can go, okay, 9 boys wanted to go bowling. Out of 21. Sorry, I've made a mistake there myself. I'll quickly edit that. Okay. So, in this situation, 9 out of the 12 boys wanted to go bowling, right? So 9 out of 12. So that'll end up being 3/4, okay? So that's the proportion of the boys that wanted to go bowling. Notice I'm only giving a single value here because it's the proportion of boys that wanted to go bowling, not the proportion of boys to girls that wanted to go bowling, or a proportion of boys to the total of boys that wanted to go bowling. It's just the proportion of boys that wanted to go bowling. What proportion of girls wanted to go bowling? Well, let's look at a similar question here. Okay, so 12 out of 18 wanted to go bowling, so 12 over 18. And that should simplify out to 2/3. Okay, so more boys out as a proportion of the boys wanted to go bowling than girls wanted to go bowling. What proportion of the students wanted to go bowling? Again, we're looking at bowling total versus total. And we're going, okay, 21 out of the 30 pupils wanted to go bowling. So as a fraction, that'll end up being, 1 second, I'll just grab my calculator to make sure I get this one correct. I'm not trying to pull the wool over your eyes. Yep, 7/10 wanted to go bowling. Okay. Now the next question here, it asks you to find x and y when they are in direct proportion. Okay. So the idea here is, as these go up, they're going to be directly proportional. Okay. So we can say we have got a ratio of 8:24 here, which means that for each 1x, we get 3y, right? So if it's 8 turns to 24, so if x is at 8, y is at 24, that means that we've got a ratio, a proportion of 1:3. Sorry, a ratio of 1:3. So if x is 9, what is y? Plug that into a calculator, you get 27. Okay, so we can plug 27 in here. Okay, now what we need to do is we need to go, okay, if y is 33, what is x? Okay, so if y is 33, what's happened here from 1 to 33? Well, that has been multiplied by 11, so this will be multiplied by 11. So x will be 11 at that point. And you'll have a few questions like that to attempt as well. I'm going to do, let's say, 2 more examples. If 3 meters of cloth cost 23.55, find the cost of 7 meters. So 3 meters, 23.55. So we have got a ratio here where we can go, okay, let's do the unitary method. Let's turn this into 1 meter. How much does 1 meter of cloth cost? So 23.55 divided by 3 ends up being, okay, we get €7.85. Okay, so that's the cost of 1 meter. Now to find the cost of 7 meters, we'll again use that unitary method, and we'll multiply this here by 7. And from that, I've done, again, using my calculator, 54.95. One last example, and this one's going to be a bit odd, because you'll notice, wait a second, one is asking for it in terms of changing the kilometers, one is asking for it in terms of changing the euro. So the thing here that you need to note is, if we're saying 100 kilometers travel, so the vehicle can travel on 100 kilometers, on 12 euro worth of petrol, then we can also say that's the same statement as a vehicle can travel, a vehicle with 12 euro of petrol can travel 100 kilometers, right? So does it make sense that these two statements, they're the same statement, aren't they? If a vehicle can travel 100 kilometers on 12 euro worth of petrol, then a vehicle with 12 euro worth of petrol can travel 100 kilometers. And that might seem super obvious and simple, but that is going to be crucial for our second portion. So we'll just do the first one first. We'll do the first section here. How much petrol cost for a journey of 350 kilometers? So what we can do is we can go, okay, so 100 kilometers has a ratio of 12 euro. So 1 kilometer, it travels 1 kilometer on each 12 cents of petrol. So 350 kilometers, that'll be 12 cents multiplied by 350, so 4,200 cents. You wouldn't pay someone 4,200 cents. What would you pay them? Well, you'd pay them just 42 euro, right? let's look at that second section here, okay? So let's look at that second line. And it's going, okay, how many kilometers would the vehicle travel on 30 euro? Okay, so from this statement here, this like kind of alternate version of saying the same thing, we can go 12 euro ratio to 100 kilometers, right? So how much would 1 euro get me? So 100 divided by 12, you're going to get something annoyingly. You know what? This is going to give it to me as a fraction. I'm going to keep it in fraction mode, okay? So 25 thirds of a kilometer, and that might seem weird, but it will make sense in a second. And the reason why it'll make sense is that I'm now going to go, okay, how much does 30 euro get me? Well, we're going to multiply this by 30. So 25 over 3 multiplied by 30, that's going to give me 250 kilometers. So girls, that's our examples there. Again, feel free to pause at any point. Feel free to review over any of those questions. Ugh, this copy and paste job has suddenly moved on me. And I look forward to marking all of your work. Thank you very much. Bye-bye.